Okay, this particular this lecture is basically a synopsis of division, polynomial division. And I've written some notes here that I'll put down. I'll erase them later, but you can look at them. Actually, you know what? I might go to another screen, and that way I can refer back to them. There's two kinds of division. There's synthetic, and there is regular division. Synthetic division is just a shortcut method for regular division. And the only time you can use synthetic division is when you're dividing, your divisor is a linear polynomial. Like, for instance, if you were dividing by, let's say, 2x minus 3, you could use synthetic division. Your root becomes, you divide by the root. You don't divide by this factor, so you have to solve for x, and this is going to give you x equals 3 halves when you're done. And that would be what you would divide by. If you have 2x squared minus 3 was what your divider was, let's say that was a squared, you can't use synthetic division. You have to use regular long division, okay? So just be aware that synthetic division is nice and a good shortcut, but it doesn't work for anything but linear divisors. You divide using synthetic division. You need to use it. Number one is when this is basically uses, okay? The uses are when you need to divide for the rational root theorem, and that's when you have a polynomial whose degree is greater than 2, it's bigger than a quadratic, and it does not factor. There's no way that you can figure out what because you don't have any tools to solve something bigger than a quadratic. We have the quadratic formula, factoring, completing the squares, that works on quadratics, and it works on some fourth degrees. But if you can't use those techniques on a power that's higher than a quadratic, you can't solve it or you can't find the roots. So if none of those factoring or any of those techniques work, you would use the rational root theorem to find a root. Remember, and we'll talk about that in a minute. I'll go ahead and review that. And once you find one of those roots, you can break it down to a quadratic by doing synthetic or regular division. And then you can finish solving it like you would a regular quadratic. Or if it's a fourth degree, you can maybe find 2 rational roots and pull them out through division. And so you reduce your polynomial from, let's say, a fourth degree to a second degree. And once you get it down to a quadratic, you have all the tools you need to finish. So those are the different uses. Again, they're good for rationals when you need to find your slant asymptotes. And you'll also use it to break down polynomials. So what I'm going to do is I'm going to go ahead and factor this completely. These would be the kind of directions you would be asked, is find all the roots or factor completely this polynomial. Well, this is a cubic and it doesn't factor. I can't use the quadratic formula on it because it's not a quadratic. So what I've got to do is find some roots, at least one root that I could, assuming it has a rational root. If it doesn't have a rational root, then you're out of luck. You can't do it without a calculator. But remember, the rational roots come from P over Q. And you put all your factors, and I made this fairly easy. So you're looking for plus or minus factors of P over Q. Those are possible roots that you could pull out of this. So that would be plus or minus all the factors of 15, which are 5, 3, and 1, over all the factors of Q, which this is a 1 right here, so they're just going to be 1. So I'm not even going to worry about that. So my possible factors are plus or minus 5, plus or minus 3, plus or minus 1. Oh, and I forgot 15 is another possible factor. So those are all the possible factors. The rational root theorem states that P of a root, let's say some root A, when I plug it into this, when I actually solve it, I'll get 0. In other words, if I get a remainder of 0 by either division or plugging it in, putting in like 15 for my x, then I'm going to get a 0. So I can test this pretty quickly on my calculator. What I can do is I can plug in P of 5. If you have a graphing calculator, you're looking to see what that is. P of a negative 5, P of 3, P of a negative 3, until you get a hit, until one of these comes out to be 0. Okay, so I went ahead and wrote out the different factors, and then I didn't have a calculator, so I would have plugged all of these in, and I would have got, what happened was when I plugged them in, I'm pretty sure it was 3. I did this a while ago, but I'm pretty sure that 3 was the only one that worked. So what you're going to do is you're going to use synthetic division to see if you get a 0 remainder. So the rest of these, when I plugged them in to the calculator, they came out as non-zero for the rational root, when I plugged them into my function, x cubed minus 4x plus 15, it did not give me a 0. So P of 3 should be the only one that works. And again, I can't remember, so this is good. We'll show you how this is very helpful because you'll find out if it works or not. So there's my function, and I'm going to try 3 as my root, all right? So, and it was either 1 or negative 3 or a negative 3, so we'll try both of them. So remember, you bring down your coefficient. This is 1x cubed. You have to account for your x squared. Don't forget, you have to have every power in your polynomial accounted for. So the x squared, I don't have any, so that's 0, minus 4, and then 15. Okay, and then 1, and then I'm going to go ahead and multiply 1 times 3. That's 3, add 3. 3 times 3 is 9. Positive 9 and negative 4 is a positive 5. 5 times 3 is 15. That gives me 30, not a 0. So let's try a negative 3. So I think I'm remembering the number right, but evidently I'm not remembering the root right. So we're going to once again bring down 1. 1 times a negative 3 is a negative 3. That gives you a negative 3. A negative 3 times a negative 3 is a positive 9, which gives you a positive 5. There you go. Positive 5 times a negative 3 is a negative 15. There's my 0 remainder. So x equals a negative 3 is a root, which means that x plus 3 is a factor. So now my polynomial, I factored it. I know that I have an x plus 3 out of there. And what's left is every time you divide by a power of 1 or a factor of 1, this cubic becomes a squared. This started as a cubic, so now it becomes a squared, an x, and a constant. All right? So you always lose a degree when you divide by a linear factor. You lose a degree, which is the whole point of factoring, is to break it down further. So now it is a quadratic. X squared plus x plus 5. Factors of 5 that add to 1, there aren't any, so this will not factor. So that's the only rational, or that's the only rational root. Rational means it can be written as a whole number or a fraction. This answer is going to be something beside rational, but that's okay because now that I've got it as a quadratic, I have the quadratic formula. I can complete the square. There's multiple. I can't factor it, but I can do the quadratic formula or complete the square. So let's do the quadratic formula. A is 1, B is 1, and C is 5. So a minus 1 plus or minus b squared, 1 squared is just 1, minus 4 times a times c, all over 2 times a, which gives me a minus 1 plus or minus 4 times 5 is 20. 1 minus 20 is a negative 1 minus 20. Is that a negative 19? I guess it is. Okay. Over 2. And I can't really simplify that. That's going to give me a negative 1 plus or minus I. I can pull the I out of 19 all over 2. Okay, this is going to look a little odd, but it's going to be the actual factored form. P of x equals x plus 3. Whoops. Okay. And then x minus my first complex factor, which is a minus 1 plus or minus I square root of 19 over 2. Oh, that's not plus or minus. It's just one of them. Yeah, we don't want them both written in the same one because they're different factors. So a minus 1 plus I square root of 19 over 2. And the other factor is x minus 1 minus I square root of 19 over 2. Okay? And that's a little strange looking, but that is actually my factored form. I probably wouldn't ask you to factor something that came out looking like that. I would probably just ask you to find the roots. So at this point in time, you would have your roots. So your roots would be, here's one of your roots, here's 2 of your roots right there. And then the other root would be x equals a negative 3 that you found by the rational root theorem. Okay, so just to make sure everybody's clear, when you're given a polynomial that is cubic or something you can't factor, you don't have a quadratic, you can find the possible rational roots and plug them into the polynomial. When you get a 0, which you get right here, then you know that's going to be a root. You know what? I remembered wrong. This would have been not equal to, and this would have been my 0, because when I went over there, the 3, this would have been the one that actually worked, because when I tried it over there, that was the one that, oops, that's not an equal to. That was the one that worked when I went over there and tried it. So this is actually a root. This is not a factor. So the positive 3 didn't work, but the negative 3 did. So this is the one that ended up being the root. Okay, so I went over here and I used synthetic division to get it to actually give me what I wanted, or to factor out what I needed it to factor out as far as dividing out the 3. And so it did that, and once I divided out the 3, I got a remainder of 0. I'm just walking through, and that told me that this was what was left. And then once I had it down to a quadratic, I could use whatever I needed to use to finish it, and I ended up just using the quadratic formula.